Okay, so let's look at some of the measuring and test equipment. Definition. Defined according to how it is controlled and used. Controlled for required accuracy. You know, when somebody buys a piece of equipment, a lot of times it's so difficult to buy a piece of equipment, they try to get as much as they can at that time because they may never have another opportunity. So what happens is this. Companies will overbuy. You may not need a frequency range this wide. You only need a frequency range this wide. But yet they'll buy this, and now that particular device has to be calibrated, not for this much, but for this much. So the cost can increase itself, literally on that. And so you can use this particular thing for determining acceptance of a product or material. Do you have incoming inspection on materials and things like this? Sure you do. How about you? You do too, so, and you probably too. That's a big issue a lot of times. You can buy specialized test equipment to do essentially that, especially on cables. They'll use automated cable testers to determine if the cable has continuity and it's hooked up right, things of that nature. Now, what do we take a look at as far as devices that are intended to be used to make measurements? You know, in the past, they used a lot of individual pieces of equipment. A voltmeter, oscilloscope, spectrum analyzer. They were individual pieces of equipment. Desktop. Today, they've moved more and more towards cards for the instrumentation. You want a spectrum analyzer? Here's a card to do it. You want to have something to measure temperatures? Here's a card that can do it. And so what happens here is you've got these different things, like you've got a transducer. Now there's a little bit of confusion. Here's a transducer and here's a sensor, isn't it? People use those synonymously. They're not synonymous. What is a sensor? A sensor is something that's used to measure a physical property, like temperature. Okay? Or like, temperature is a good idea, basically, or maybe whatever. And then they'll take and convert that to a voltage. And so the device or the unit is called a transducer that converts this physical property over to a voltage. Now that voltage now is going to be measured. You could use a DVM, digital voltmeter. You could use a multimeter, or you could use an A to D converter. In fact, A to D converters are used almost extensively today, aren't they? So what happens here is the analog digital measuring instrument. It could be still an individual piece of equipment, but usually it's an A to D converter. In fact, most stuff is a data acquisition system now. In fact, your digital voltmeter is a data acquisition system. Your spectrum analyzer is a data acquisition system. Your oscilloscope is a data acquisition system. Complete thing. You've got actually that. So what happens is you've got a transducer that gives you the voltage. You've got something that's measuring it, whether it be voltage or current or whatever. And then you have, you record that. You get that with the measurement instrument. And then you'll either do some calculations or you'll do some displays. For instance, on an oscilloscope now, are you all familiar with what an oscilloscope is? It measures effective electrical signals and displays them. Original oscilloscopes used what they call a CRT, cathode ray tube. Today what they do is they have a data acquisition system, and it does calculations and it displays it on a computer screen. And so it tells you here's what it looks like, the wave shape, and here's what the maximum voltage is or the least voltage. So that's done through a computer system itself. So what will happen is that you'll have this instrumentation. You'll use a computer system that then will display it on a terminal. Not only that, the data can be acquired and sent where? If you're on your own network, it'll actually go there. Some people send it over the internet. I personally don't believe in that. And that's only because I have about 40 years experience involved in this. The internet is not secure. I don't care what they say. It is not secure. Maybe this is not that critical of data. You can get by with it. But it just isn't secure. And so, therefore, I believe that it should be your own internal network. And you can make that. Do you have an internal network at your facility? It absolutely does.
Our control computers are on a network, but it's not connected to the outside at all.
That's right. So that works out very well.
Right.
Hewlett Packard, when they first came out with email as a mission critical application, they put in their own email mailing system with the system with disks and everything were redundant, and it had an uptime of 99.999%. And you could send a message anywhere in the world with that system, and I think they had the criteria within 5 minutes, but usually it arrived there within 15 seconds, literally. And they viewed that. But a lot of other companies used, the Google and all this kind of stuff and that kind of thing. And so you've got to be concerned about that. You can do it internal. So you've got all this stuff that you put together to make these measurements. Many of the things have to be calibrated, especially the A to D cards and things like that. How about the sensors? Do you think they need to be calibrated? Yes. Absolutely yes. As far as the display system, not necessarily. If it's just a computer display displaying the information, then you don't. Excuse me. Kevin, can I call you back in 15 minutes? 15 minutes. All right, bye. He's in an airport waiting for a flight. Seems like all of us are going to be doing that pretty quick. Okay. And as far as the disciplines that you have for measurements, you've got dimensional, electrical and electronic, mechanical, nuclear, optical, physical, and chemistry. Now, I was at a facility where they had most of that. They had nuclear, they had mechanical, they had electrical, dimensional, and they didn't have optical, but they did have chemical, specifically. And they were accredited in each one of those areas, specifically. So these are different disciplines. Again, electrical is a lot easier than some of the other ones. You have to realize that.
No temperature.
What's that again, please?
No temperature. Temperature discipline.
Yeah, they had a person who was temperature specialist.
But where does under the different discipline, which the temperature falls under which one?
Oh, the temperature actually fell under the. Well, I guess they kind of put it under physical measuring the temperature. One person was measuring wind speed, and the reason they were measuring wind speed and keeping track of it all the time because it was a nuclear facility, and if they happened to have something that got loose, they wanted to know where it was going. So they had to keep that up specifically. And a lot of times commercially, you need flexibility. Efficiency may be compromised for a lower initial cost. And you can find these different examples in all the disciplines themselves. If you were to look at mechanical and electrical, there's more similarities than differences, especially when it comes to record keeping and procedures and that kind of stuff. Lack of versatility. This is special M&T. You have some specialized M&T, don't you?
Yeah.
Yeah, specialized, done for a specific purpose.
Yeah.
You've used general purpose equipment to create this.
Right.
How about yourself? Do you have specialized equipment? You might, but I'm sure you do. I'm sure you do. At General Dynamics Pomona, they had over 300 pieces of specialized test equipment. It was all assembled together to do testing. Of course, the federal government stopped giving money to do that. Each one of these systems cost anywhere from, I would say on an average, $750,000 to $2 million. And that. And they had like 3 or 4 levels they were testing, and the government paid for them. Then they decided, we'll just do final test and pay for that. So a lot of stuff is not being tested as well as it should be now because of that. But then again, they may be specialized, but it's a lot more efficient to use it, to do this testing. Do you think the cable should be tested? What do you think?
It always do.
Yes,
You
they
measure
always.
loss and you connectivity loss.
Well, what I mean by that is they say you buy cables from an outside source.
Right.
And so one of the things you need to have on the receiving inspection is you need to test that cable to see if it's wired properly
Yes.
and has the proper impedance. So it definitely has to be done
Right.
in acceptance testing. Then there has to be a situation that maybe there's a very critical cable in this test system that you've treated together, and so they test it every maybe 3 calibration to make sure that it hasn't shaken and broken loose. You realize cabling can be a very, very critical area. To give you an example of something like that, there was this facility that was using a smaller computer to communicate with a bigger computer. It was hardwired. It wasn't internet. It wasn't the typical LAN as today. It was back in the era where manufacturers had their own computer interfaces. And what would happen is that it would just keep failing at a certain time of the day. And you know that old hardware-software argument? It's hardware. No, it's software. It's hardware. So I was actually working in the software area, and they said, we want you to go out there and look. It's just not software, it's hardware. What do you mean? Our hardware technician says it's not that. So I went out there, and it seemed to fail every 2 to 3 o'clock in the afternoon. It was in Pomona, California. And it gets kind of warm there in the summer, and usually air conditioning can't handle it. And so they always under air conditioned stuff, right? And so what happened is that I went out there and I asked them, so I went to the weakest link. And the weakest link is always the cabling. It says, who made the cable for you? Now you could buy the cable made by the factory at HP, or you could have a technician from the office make the cable. That's like hand making it yourself. That type of stuff is not as quality control, is it? And then what happened is I decided to take it apart and look at the cable. And being nearsighted a lot before, I could take and look at something like this, and about this far from my eyes, it was like 4 times magnification. So I opened it up, it was failing, and I looked at it really close, and I saw that, doggone, look at that. I saw somebody had nicked it, the wire, when they made it, and the vibration of the cabinet itself, the fans and all this stuff, caused it to snap. But it was together. And as it got hotter during the day, guess what happened? It separated. And of course it didn't separate, it stayed that far apart, it was doing this. This is causing all the noise and problems. So all he did is do a good solder that, fix the cable, and work from there on. So unusual things can happen. So the special purpose M&TE can actually test for these kinds of things. Examples are electronic test sets, dimensional gauge. There is a trend, a way that we're going now to make sure that we come up with a test system that will efficiently test this equipment. Try to take out the human aspect, because the human aspect is the art, isn't it? The human aspect is the art of that test. Okay? Dimensional gauges, practical gauging methods. Anybody ever worked with dimensional gauges? What are some of the problems that you had with the dimensional gauges?
Well, if your temperature.
Always temperature, isn't it?
Always temperature. And
Yeah. I mean, dimensional pin gauges,
Uh-huh.
interstate limits. Yeah, they have to be maintained.
You have to check them quite a bit, don't you?
right.
But some people say, gee, this is not anything electrical. I don't need to check that very often. You need to do it.
And also
Temperature and cleanliness.
cleanliness.
And cleanliness, that's a very good issue right there. Inspection by attributes. You've got these things, dimensional gauges, as far as go, no-go gauging elements. They're still used. They're pretty easy. This plug will go in or not go in.
Right.
Is that kind of situation involved here? They're very fast to do. Still, they're kind of necessary. Example is electrical plug gauges for inspecting functional size of hole. This is kind of showing you one of the issues here. Here's the hole. Here's 0.250 inches plus or minus 0.0005 inches. Here's a plug that goes in. Here's another plug that it won't go in. Sometimes you'll have these put together on one thing and you'll pass it through and then it tapers up the other and it doesn't go through. So you'll use that type of
Do a gauge or something. Okay.
the gauge that situation on that.
Thread gauge is the same way. You got to go, no go.
Yeah.
Thread gauges.
And in a lot of cases, that's all you need. That's all you need. Now, what happens here? Automatic test equipment, AT, two kinds. Now, what we mean by this is that if you go to some of the earlier systems they did at General Dynamics, they did not have computers in them. They actually had control boxes where they hardwired the logic for the sequence of tests. And they worked well. In some cases, it's still easier to do that. But today, and back then, they were very progressive and they started incorporating general purpose computers in the test. It was easier to build, it was faster, and you could collect data very easily from that. You had flexibility. And if that particular project closed down, then you could easily program it to do something for something else. So it worked out pretty well. So much of this started happening in the late 60s, early 70s, where it was controlled by an external computer. Part of the problem is at that time, everybody considered a computer to be the big IBM for multi-millions of dollars. So you couldn't buy a computer. Not even that word could not be. So what they would do is play games. It would not be called a computer, it would be called an I/O controller. You know, that kind of stuff. Name changes. Then in one company actually had a plate they put across the front to keep seeing the lights that were flickering and make it look more like just a box. But then after people started using these things, they realized, man, these things really help solve problems. So it got a lot easier and easier to use it specifically. Then the problem with this, though, is the software quality control. It's very important. That's the sequence of instructions that you actually are running. They should be checked. They should be validated. This is one of the problems with a lot of people running Excel and other things like this. They'll write a program, do a job, and it's never been tested. Never been tested. And it can be, and they never check all the limits. They're only using it in one special little application. And then Rich says, hey, this doesn't work except for this. And then somebody by the name of John says, John, hey, I want to use it. You loan it to him, right? And then it goes there, and then it gets used in places it shouldn't have been used. So you've got to have a lot of quality control on the ATE software. And here are some quality standards they have: quality control requirements, inspection, ISO 9001, quality systems. This has become a very important issue, hasn't it? Like I said, originally it was not a requirement. It was just something maybe you might do. But it became so evident that the quality control issue is important that it became more or less a requirement now. In fact, a lot of companies will not even hire you unless you have ISO 9001 that you're working with. Section 4.11.1, establish and maintain documented procedures to control, calibrate, maintain inspection, measuring, and test equipment. That's part of that section. And in this section is control procedures. Select appropriate measurement and test equipment capable of necessary accuracy. This is the overall. Now remember something. This is the overall company objective. And within that, you have that calibration objective. Okay? And of course, you need to have calibration at prescribed intervals. For some strange reason, they always pick a year, don't they? I know cases where you had to do it every month. But they're always trying to keep it out a year, reduce the cost. I think they've gotten to the point where they're almost biting themselves in the foot. And then, of course, you have to define the process employed. Identify M&TE with a suitable indicator to show the calibration status. Maintain calibration records for inspection, measuring, and test equipment. So all this data ends up being connected directly to a computer, isn't it? Stored in a database. Now, let me ask you a question here. Do you think they buy a commercial package or write their own? Let's look at the advantage or disadvantage of this. What do you think? What do you guys do? Do you know when you do your testing? Do you send it to a commercial package or just store it as data?
each piece of equipment is stored as its own file, and it's all stored individually. We have our own system.
Did you use like Excel?
I
Or did you
don't
use a
think so.
true
I think they have
database
a
program?
MATLAB or some sort of program that we use.
Oh, MATLAB? Well, that's a general purpose package.
Yeah, that they run.
Write your own, yeah. Has that software been validated?
I'm sure it has.
Well, yes.
Because we're ISO 9001 certified. And
Okay.
You have to prove everything.
So, but there is another way to do it. You can actually buy a commercial package
Right.
that's validated themselves. In many ways, that's the better thing to do, because that package, if they're using MATLAB, was probably written by somebody
Yeah, it's written
Look.
by somebody on lab. Yeah.
in the lab. And then one of the problems with that is what?
He left.
He left
He did.
right there. How's the documentation?
Yeah.
Documentation may not even be there.
Oh no, it's there. Somebody else picked it up, and they didn't write the program, so they're not as familiar with it.
Right, but you see, the person that wrote the program should have provided the documentation,
Right.
not someone else. Now that's the point. And when you get a commercially set of systems to be able to do this, as far as maintaining these calibration records, you at least have a support issue with that. But if you do buy software from another company that's doing this task, you should make sure that source code is available. Why? What if they drop it as a product? Then you have to start maintaining this thing or change everything. It gets to be a pretty complicated issue. And then you have to make sure that the M and TE has not been used in an out of tolerance condition. Very critically you do this. Remember what I told you happened to the guy in the atomic energy situation? Been over $1 million, having to go back and recheck everything. And then, of course, you need to ensure that the environmental conditions are suitable, which means in your lab you have maintaining temperature. You know the old charts that they have? They're still pretty darn good, aren't they?
I still
have
use them.
Yeah, they're actually, that's something there that somebody wants to change or make better. You can't get any better than that. It's continuous operation, isn't it?
Yeah.
You could be taking data as far as the temperature every so often, but it still works out pretty well. Then you just have to make a note of it, whether it was in that spec or not, right? And then you file it away. I bet you they're used, I hope they're used for the next 100 years. I really do. So you've got to be concerned about the environmental conditions in the testing. Proper handling, preservation and storage of MT&E. Now here's something. Safeguard M&TE measurement and test equipment and the test facilities from unauthorized adjustments. Meaning that not anybody can go in. So you've got to be careful of this, because a lot of people, just to get by, they'll break the seal, they'll go in and make some changes and come back out. I've seen it happen. I'm sure you still see it happen. So you've got to be very concerned about this.
Thank you for watching our short samples of recent TTI seminars recorded at our Las Vegas training facility. Our non-gaming facility in Las Vegas provides a cost-effective and distraction-free venue for students to focus on training. If you are unable to travel to Las Vegas, you can join a future live class online using our web conferencing solution. If you can't devote 2 to 4 consecutive days to live training, I recommend you watch our on-demand courses at your own pace. Your on-demand subscription gives you 30 days to watch a pre-recorded seminar as many times as you like, any time of the day, and from anywhere in the world. Our teaching staff is also available to travel to your facility, so contact TTI now to discuss a solution that's right for you.